Hey everyone, Mr. Cruze here. Welcome back to another Algebra 2 review, this time Chapter 7, Part 2. Remember, your test is tomorrow, April 16th, 2013. It'll be about 20 questions long, just like your review here. Just remember that I will be here in the morning. You can always Twitter me, you can always email me, you can ask me questions at any time. I will be here at 7 in the morning as well. So hopefully if you have questions about this, you can come in and we can get them straightened out. All right, away we go then. So graph y equals log of x plus 2 minus 1. Well, logs are a little trickier to graph, right? So to do that, we're going to start off by flipping the x and y. We're going to work up through the inverse, all right? So let's switch the x and y. And then, of course, just to make life easier, let's get y by itself. So I'm going to add 1. So I get x plus 1 equals log of y plus 2. And then, to undo the log, I have to bump that base. Well, the base is 10 when it's not written. So we have 10 to the x plus 1 equals y plus 2. And then I'm going to subtract 2 from both sides. So we have 10 to the x plus 1 minus 2. Please note, the plus 1 and the minus 2 are on different levels, if you will. The x plus 1 is in the exponent. The minus 2 is down below. You can't combine those, all right? Can I make a t-table for this? Well, you bet we can. We'll start off by making one for 10 to the x. Again, we use negative 2, negative 1, 0, 1, and 2. If I plug in negative 2 into 10 to the x, 10 to the negative 2 is 1 over 100, or 0.01. 10 to the negative first is 1/10, or 0.1. 10 to the 0 is 1. 10 to the first is 10, and 10 squared is 100. Okay. Now, can I shift it? Well, you bet we can. This plus 1 means we're going to subtract 1 from x. And this minus 2 means we're going to subtract 2 from y. Okay, so we're going to subtract 1 from all our x's. So minus 2 now becomes minus 3, and so on down the line. Hopefully you can subtract 1. If I subtract 2 from all these y values, I'll get negative 1.99. I'll get negative 1.9. I will get negative 1. I will get 8, and I'll get 98. Okay, you can check those. I believe those are correct. So there we go. We have just officially made a t-table for 10 to the x plus 1 minus 2. But that's not what we were trying to graph. We're trying to graph this in the beginning, correct? So what do I have to do? Well, I have to undo what I did in the beginning, which the very first step was flip the x and y. So guess what the last step is? Flip the x and y! So I flip it back. So negative 1.99, negative 1.9, negative 1, 8, and 98. And then we have negative 3, negative 2, negative 1, 0, and 1. There is the t-table we're going to graph. Okay? So let's graph it. Negative 1.99, negative 3. And that will be right here. Negative 1.9, negative 2, be right there. Negative 1, negative 1, 8, 0, right there. Ooh, wow, that gets really steep. Anyway, make sure, again, you have the double arrows. This time you'll notice the vertical asymptote, when it's a log, it has a vertical asymptote. You'll notice the vertical asymptote is x equals negative 2. Might have something to do with that right there. But anyway, there's your graph. Again, most of what I care about is going to be your t-table. I mean, the graph should have a good picture to it, but really that's about as good as you're going to get. Okay? Right log base 16 of 2 equals 1/4 in exponential form. Really easy. Bump the base. Log of 16, well, I'm going to bump the base by 16. Well, what happens to the 16 and the log of 16? They cancel each other out. So you're left with 2 equals 16 to the 1/4. And that is it. That's seriously all you have to do. Number 10, find the inverse of y equals log base 4 of x. Well, switch the x and y. And the only thing you have to do left is bump the base, which is 4. So 4 to the x equals 4 to the log 4y, but again, the 4 and the log 4 will cancel. There's your inverse, 4 to the x. Okay? So far, so good. Number 11, write it as a single logarithm. Well, remember we have to deal with powers first. The 3 comes up, the 4 comes up. So we have log base 3 of x to the third plus log base 3 of y to the fourth. Since they are of the same base, addition becomes multiplication. You multiply the arguments together. So this will be log base 3 of x to the third, y to the fourth. It's a single logarithm. You win the day. Same with this one, powers first. So we have log of 9 minus log of 3 squared, which, hey guys, guess what? 3 squared is 9. Convenient. Honestly, guys, you don't even really have to combine these. Look what happens. What's log of 9 minus log 9? Well, guys, guess what? What's 9 minus 9? 0. What's log of 9 minus log 9 going to be? It's going to be 0. This adds to 0. You're only left with log 3. That's it. Now, technically, you could do this another way. You could do log of 9 over 9 plus log of 3. 9 over 9 comes out to be 1. Okay, plus log of 3. And of course, you'd multiply, so you still get log of 3. All right. 13, let's bring the power up. We have log base 4 of x to the 7th plus log base 4 of z to the 12th. Again, multiply, so you get log base 4 of x to the 7th, z to the 12th. And there we go. All right, 14, expand the logarithm. Well, we're going the other way this time. So multiplication breaks up into addition. So log base 6 of 9 plus log base 6 of x, because those are multiplied together, plus another multiplication, log base 6 of y squared. And the only thing left is to bring the powers out front. Log base 6 of 9 plus log base 6 of x plus 2 log base 6 of y. And that's about as far expanded as you can get it. And that's all you have to do. The rest of them are just solving equations. So, pretty easy. If they're logs, you're going to bump the base. If they're exponential, you're going to log them. All right, so here we go. We're going to bump the base. Base is 10. 10 and the log will cancel. So you get 6x plus 20 equals 10 to the third is 1,000. Subtract 20, so 6x equals 980. And then you just have to take 980 divided by 6. 980 divided by 6. 163 point, it says nearest thousandth, so 333. And there you go. All right. This one, before you can bump the base, you have to make them a single logarithm, like 15 was. So the plus becomes multiplication. So that'd be a natural log of 4x equals 7. Bump the base. When it's natural log, the base is e. So the e and the natural log cancel. You get 4x equals e to the 7th. So x is going to be e to the 7th over 4, which equals, let's do e to the 7th divided by 4. 274.158. There you go. 17, we're going to log both sides. So log of 27 to the 3x equals log of 81. The 3x comes out front, so we get 3x log of 27 equals log of 81. Divide both sides by log of 27. You get this. You're running a little out of room. 3x is going to equal, well, let's see. What this comes out to be. That. And then, aren't you going to divide that by 3? Yeah. So you can go ahead and do that. Anyway, it becomes 0.444. Sorry, I'm skipping steps there. I just wanted to make sure we didn't run out of room. You're going to basically figure out what log of 81 divided by log of 27 is, and then divide by 3. Okay, I hope you know how to do that part. 18, similar to 16, you have to make them a single log. Only with the minus sign, it becomes division. So that'll be 4x over 3 equals 2. You bump the base. So it'll be 4x over 3 equals 100. Multiply by 3, that'll be 4x equals 300. So what's x going to equal? 300 divided by 4, which I believe will be 12. Oh, no, just kidding, 75. 12, really. I don't know what I was thinking there. Anyway, 75 it is. Okay. I guess I was thinking how many quarters are in $3. That's what I was thinking of. Okay. 19. 4 to the 2x minus 3 equals 26. I'm going to log both sides. Log of 4 to the 2x minus 3 equals log of 26. The 2x minus 3 comes out front. You're, of course, going to divide by log 4. So we get 2x minus 3 equals log of 26 divided by log of 4, which is what as a decimal, I wonder. Let's see. Log of 26 divided by log of 4. You get that, 2.350. And then it's just an algebra problem. Can you add 3 and divide by 2? Sure you can. You get 2.675. All right? Really, at a certain point, they just become Algebra 1 problems, right? This one, make sure you don't write through it. 2e to the 3x. Well, I'm going to subtract 4, so I get 8. Divide everything by 2, so we get e to the 3x equals 4. Because it's e, instead of just logging it, I'm going to natural log both sides. Natural log of e cancels, and you're left with 3x equals natural log of 4. So x is going to equal the natural log of 4 divided by 3, which will be what? Natural log of 4 divided by 3. 0.462. And there you go. Again, if you need any help, I will be here in the morning. Please look back at your notes. There are other videos. I'll have the links for them down below. Just please, please study, 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 all right? Good luck studying, and I'll see you tomorrow.